Okay, so I'm gonna make one more video walking through midterm one. I took a picture of like every page of my midterm, and then I'm just gonna go through like my process. I didn't get all the questions right. I got 4 wrong, so I'll go through those too. Because 10 of the questions on midterm 2 are gonna be from this one, so figure we'll go through those. I don't know how long this is going to take, but I'll go through how I got the answers and my sort of like strategy in getting them. So yeah, let's get started here. So question 1 was just a an output gap question. So it said, in which years is it experiencing an inflationary gap? So I just wrote down what that means right here. Just means that actual is greater than potential, and then you just go through, find what years actual is greater than potential. That one's not too bad. This one. Consider a small economy with real GDP of $1 billion and total number of hours worked equal to 5 million. There are 125,000 employees in this economy. Which of the following is best measure of labor productivity in this economy? So there's like a lot of info in this question. Just what's important is to like look at exactly like the wording of the question. So whether it's per hour worked or per employee worked or whatever, productivity is not usually measured by like employees. Like per hour worked is a more common measure of that. And then from there, it's just like a matter of kind of like going through them. Once you cut off both the employed workers, you are able to determine. So that kind of leaves you with C or A, and then that's just setting up your like a fraction and canceling them off, and you get 200 instead of 20. So that's that one. This one, there was no right answer, and it was pretty hard to determine, so I'm just going to skip over that. Okay. Suppose a price index for a certain basket of goods and services has a value of 150 in 2018 and a value of 156 in 2019. This index suggests the cost of the market basket of goods and services. Okay, so we want to see how much higher it was. So how you find how much higher something is we need like a rate, right? So our rate is we're going to calculate that by doing new minus old over old. So in this question here, the new is 156 and the old is 150. So it's 156 minus 150 over 150, which is the same as 6 over 150. So that's like how much it's changed. When we multiply by 100, we get the percent that it's changed, which is just 4%. So then you can see that it's 4% higher in 2019 than 2018. Not any of these other ones. Okay. Labor force survey gives you a bunch of numbers. What's the unemployment rate? Unemployment rate is just the number, it's the unemployed people divided by the total labor force. So what's important is it's people that want to work. So like the category, how you're unemployed, there's 2 things you need to be unemployed. You need to be actively searching for a job, and you need to be like encouraged. There's a lot of like discouraged workers or whatever, so you have to be encouraged. Those are the 2 things. So here it says the employment is that, and then the labor force, so that includes the unemployed people and the employed people. So the top number is just the unemployed people, and then it's divided by the labor force, which is unemployed plus employed, gives you the total thing. Unemployment rate. Next one. Consider short-run fluctuations in real GDP around its trend value. We can say that such fluctuations are. So that's like, there's like a graph in the textbook. It looks like something like this. So this is like potential GDP over time, and then this is like real GDP. I don't know if you guys remember that graph. So like anytime we're above that's an inflationary gap, and anytime we're below is a recessionary gap. And these kind of fluctuations of real GDP are called the business cycle. That's what they're called. Around its trend value. So the trend value would be potential. So this is the trend value or potential. Yeah. Next one. So the missing value of CPI. So how do we do this one? Exact same thing with the new minus old over old one. So we'll go through it. In 2019, blah, blah, blah. Okay, the missing year. So how did we get from here to here? It gives us what the average gains were. So it says from 2017 to 2018, there was a gain of 2.3%. So you can plug that in up here. So X would be your new. So this would be X right in here. Can I put that in? Yeah, right. Like right in there, that's where X is. So that's your new minus your old, which was 130.4 over your old gives you 0.023. So that's what the average gain is. That's right. And then we're just going to cross multiply. So 0.023 times 130.4 gives you that. And then add it to the other side gives you 133.4. And if you're not sure about that, you can always like do it the other way too, and you can verify that. Okay, assume that Sarah agrees to lend. I just want to make sure that you guys can see everything when I'm in like this. Yeah, okay, you should be good. Okay. Assume that Sarah agrees to lend $100 to Sam for 1 year. Sam agrees to pay Sarah $110 at the end of the year. If inflation over that 1 year is 7%, what real rate of interest does Sarah earn on her $100? So the real of anything is equal to nominal minus inflation. This is the little formula. So it says inflation over the year is 7%, and she wants to, and Sam agrees to pay Sarah $110. So $110 is, that's the initial amount, right? So that's 10% interest. So the nominal amount, the amount that he's like paying her that we can see is, okay, it went from 110 to 100. So what like increase was that? That's a 10% increase. And then, so that's the nominal. And then the inflation is 7%. So nominal minus inflation equals 3%. So her real rate of interest is 3%. Okay, these graphs, they're like the opposite that you think. So you just really have to pay attention. Like when the graph has an upward trend, that means it's depreciation. And when it has a downward trend, we're seeing appreciation. So that's like the only real trick to this graph. And then you just have to figure out which one works. So January 2018 is here. Depreciated from 2018 to 2020. So you can see like a general upward trend here. I drew a big arrow from here to there. So that's when it depreciated. It went up. It depreciated. When the exchange rate goes up, that means it costs more of your dollars to buy a dollar of someone else's currency. That's the exchange rate going up. That's what this graph is measuring. So that means that your dollar has become less valuable. So it has depreciated. That's that one. Suppose a Canadian firm imports $5,000 worth of Frisbees from China and sells them for $10,000. Okay, so this one I actually wasn't sure. I kind of guessed it on the exam, but it does make sense because it's like it's kind of like a value added question. So what was the value added to your economy? So they came in for 5,000 and then you sold them again for 10,000. So the value added in your economy, the money that stayed in your economy was $5,000. So your GDP increased by $5,000. This one, purely out of the textbook, 6%. What is it? It's unemployment rate. The inflation rate, if you guys are curious, is about 2% a year. That might come up on this midterm. The inflation rate in Canada right now is about 2%. It's been that way for quite a while now. The real growth rate of GDP, I have no idea what that is. The nominal interest rate on a 10-year government bond, that's something that changes like every day. the nominal interest rate. So that wouldn't be like a trend. That wouldn't be a trend, and neither would the output gap, because we've had recessions and inflationary gaps like recently. Like that's not a real trend. But the employment rate is somewhere between 6 and 7%. Okay. This one I got wrong. So like unlucky, because like I narrowed it down to 2 and then I clicked the wrong, or I circled the wrong one. Let me just check which one it actually is. It's hard to tell in the black and white. Okay, so the right answer is A. Why are transfer payments excluded from the government in the calculation of GDP? So I'll go through this as like my process, because I got it wrong, but like my process was right. So I just like go through and eliminate the ones that immediately are like not correct. So there's never anything that's small enough to ignore. That doesn't make any sense. So we can get rid of that. Difficult to assess the market value of a transfer payment. So a transfer payment is like when you're paying like senior pensions and stuff. So that's like very like trackable. So it's not difficult to assess the market value of that. Excuse me. Because they are not counted as income by any economic agent. So that's also not true, because like that's a fixed income. Like the example I used of pension plan is fixed income for seniors, so that would be their income. And then it's down to they do not generate additional real output to the economy, and they do not represent the purchase of a good or service. So I guess they generate real output because the seniors receiving that income would then purchase stuff with it, which would count as consumption. So I guess I could see that, which narrows it down to A, because they do not represent the purchase of a good or service, like not directly. So that makes sense. That makes sense. This one, okay, I want to talk about this one. This is like calculating GDP from expenditure side and income side. I'll do like both sides so that you guys can see how that works. So from the expenditure side, it's just like our AE formula. So it's just C plus I plus G plus NX. That's it. It's only like purchases. And then the income side is a little bit trickier. It's factor incomes plus non-factor incomes, and I'll go into what those are. So maybe I can just take a screenshot of this. Perfect. Okay. So let's go through. I'll do what's important to note with these questions is that both sides should equal each other. That's the idea, is that because all income is like eventually spent on something, both sides equal each other. So if it says calculate it from the income side and you know how to do it, and you can calculate it from the expenditure side, just do that and it should be fine. I think you should also be able to just add these all up and divide by 2, but sometimes the key is sometimes they don't give you all the variables with this, which they shouldn't do, but if they want to be like nitpicky about it. So just like be aware of that. If you notice that like one is missing, then you can't just add them all up and divide by 2. So okay, so we'll go through them. So let's pick we'll pick red for expenditure. So consumption. So consumption expenditure is obviously C. So from the expenditure side, we have 5107, and all of these variables are only going to be used once. That was a really bad check. I'll check them off over here. Better. Okay, and then investment. So that's just gross investment. It's not investment income. That would be from the income side. It's just gross investment. So gross investment is 1850. Then G is just government purchases. Like, don't worry about government subsidies or taxes or anything, because it's just like what you're purchasing. It's the expenditures. So we just have to find government purchases and add that. 2, 3, 1, 5. And then NX is exports minus imports. So exports is 954. And imports, remember, minus is 982. Okay, cool. Do I have a calculator somewhere? Yeah. Okay, so 5107 plus 1850 plus 2315 plus 954 minus 982 gives us 9244. And realistically, you guys, you should have some enough time on the exam to go through these questions and do it from both sides, because it's just gonna really it's gonna make sure it's correct, So we'll do the other side. So the income side is a bit more complicated, but I'll explain how it works. So we have three different factor incomes, and those are wages and salaries, investment income, and I'm just going to pull up my textbook so that I can make sure. Give me a hot sec here to find this. Not that. Oh, was that it? Hey, okay, cool. We found it. So wages and salaries and any supplementary income, it says. And then investment income, and the third one is business profits. And then we have non-factor incomes. So factors, remember, are things that we use in production. So wages and salaries would be given to workers. Investment income, so that would be on machines and stuff, and business profits, kind of self-explanatory. Okay, so non-factor incomes are depreciation and taxes less subsidies. So we're going to add depreciation in this case. We're going to add it. The only thing we're subtracting is subsidies. So, yeah. Helpful to have a textbook. So this is 6, 4, 2, 3. Check. Investment income is 652. And business profits is 1256. And then depreciation is 425. And taxes less subsidies, so GST, goods and service tax, 613 minus the subsidies to firms, 125. And if you add all these up, you should get the same number. Plus 652 plus 1256 plus 125 plus 613 minus 125. Yeah, you do. 9, 2, 4, 4. So there's a couple ways of going through this question. The easiest one to remember by far is the expenditure side. That was a really bad circle. The expenditure side one, because you only really have to know 5 things. This one you only have to know 6 things, but it can get a little bit trickier just because this isn't a formula we know, but this is a formula we know. So I'd recommend learning that one if you can. Whether you want to memorize it, whether you want to rely on just adding them all up and dividing by 2, a lot of them are viable ways. And then I just say calculate it from both sides and make sure they match, because they should. And if they don't, there's 2 reasons why they don't match. One is you messed up. The other is they haven't given you all the variables. So that's why it's kind of important to know it. But definitely, if you can, calculate it from the expenditure side. Okay, which of the following is the best example of cyclical employment? So we have three types of employment. We have cyclical, frictional, and structural, as well as seasonal. So I don't remember those like too well, but types of unemployment. So, that's types of unemployment. Okay, so we have seasonal, which is really easy. It's just like if you're working part-time work, so like any summer jobs is seasonal unemployment because you're not employed throughout the whole year, right? And then we have frictional. Frictional is the most, like, I don't know if it's the most common form, but it's the one that you'd see the most. It's just like when you quit your job to find a new one, you're frictionally unemployed. Like you're going to get a new job. You're kind of unemployed by choice. The other example of that is if you're laid off just because there isn't enough demand. That's what frictional is. So you could have a job if you wanted one. In essence. Structural unemployment is you don't have the right skills. You don't have the right skills. So a farmer can't be employed at a tech company. That's being structurally unemployed because you don't have the right skills. And then cyclical is I take back what I said about frictional earlier being that second thing. Cyclical is when you're laid off because of demand. That's what frictional is. So cyclical. We'll go through them. So a worker quits their job to find a better one. That's being frictionally unemployed. You could have a job, you just don't really want one, or like you don't have one in this moment. An iron worker cannot find a job in Alberta because all job vacancies are in Quebec. I'd say that's structural. They're not in the right spot, right? Like the farmer, they could find a job as a farmer, but not in like Silicon Valley or something where all the tech companies are. So they're structurally unemployed just where they are. But the most common example of being structurally unemployed is technological advances. You don't have the right technological skills. And inflationary pressures have led to higher wages for all jobs. That's not a case of unemployment. I just wrote no. So go through them, kind of narrow them down, and use your best judgment. So this is we have this like question twice, but like the thing they asked for is a little bit different. So it took me a while. It was a little tricky. It messed with my head, but figured it out. Assume the output of all three goods is consumed in the economy and there are no imported goods and services. If 2018 is used as the base year, then the consumer price index in 2019 was approximately. So if they use whatever year they use as the base year, that means the CPI in that year is 100. That's like the default is always 100. So that's like right here I wrote 100. Just remember that. And then we have to find out how much it goes up by. So what you do is we calculate GDP in the base year. So I'll take a snip of this and go through it. I'll take this too, just in case. Move this over a bit. So GDP is just all the goods. So in the first year, it would be 1 times 100 plus 2 times 200 plus 5 times 100, which is 100 plus 400 plus 500, so 1,000. So that's our base GDP. Put one too many zeros here. And then in the next year, it's 2 times 120 plus 3 times 200 plus 10 times 98. I don't want to do that mental math, so 2 times 120 plus 3 times 200 plus 10 times 98 gives us 1820. I'd always recommend using a calculator on a test. Don't ever do mental math. There's no point. Calculator can do it faster anyways, and it's always right, as long as you put the numbers in right. So how do we find the GDP deflator? New minus old over old equals, this is going to be 820 over 1,000. So we can say that it increased by 82%. 82%. So how do we turn that into the deflator? We're going to add that number to 1, pretty much. So we're going to add like 100%, which gives us 182. That's the GDP deflator. Or sorry, that's what the CPI is. Where's the next one? Yeah, the GDP deflator is a little bit different. We'll get to that. So the CPI is 182. Base year was 100, and then it went up by 82%. So it got to 180, or really 182, but it says approximately, so that's okay that it's a bit off. Okay, so economic theory argues that there will be fewer real effects from inflation as long as the... So, when I talked with a couple of my friends, they were like, well, inflation can never be fully anticipated, so like D cannot be correct, which is probably right. But this is economic theory. Theory doesn't have to be reality. That's like the point of theory, right? So if inflation is fully anticipated, if we know how much inflation is going to be in the next year, then we can adjust all wages, everything accordingly, so that nothing really happens. Yeah. So some of these other ones, like anticipated rate of inflation is more than the actual rate of inflation. So sometimes you'll see a question that's like, there'll be questions like a worker negotiates a raise of 4%, and inflation is X. So let's consider 3 possibilities. X equals 4%, X equals 3%, X equals 5%. So if the case where inflation is exactly equal to their raise, then nothing will happen. They will have the exact same real wage, which is the wage after inflation, right? Real is nominal minus inflation. So whatever their nominal wage was minus inflation gives us their real wage. If the inflation is only 3%, well, now their nominal wage is 4% minus 3%. Their nominal wage, wage went up by 1%. So they are better off, and the employer is worse off. So, there will be fewer effects. There will be more effects. We don't know how who it's going to affect. We know it's going to be better for the people who got more of a wage, and it's going to be worse off for the people who have to pay them, right? And vice versa here, the wage is going to go down by 1%, their real wage. Who does inflation affect the most? Well, people with fixed incomes that aren't indexed for inflation. So a raise of 4% is like indexing their wage for inflation. If you're a senior and you're earning just like 85 grand a year, we'll say, through your pension plan, but that doesn't increase with inflation, your first year, your real wage might be 85 grand, but as inflation rises, your real wage is decreasing, and so is your purchasing power. So you become worse off if you don't have an index pension. So a lot of these are like whole private sector is unaware that this is happening. That makes no sense. That's not right. Okay. The GDP deflator in 2018, like I underline that because it's different. The last one here was 2019. So what's the GDP deflator in 2018? 100. The GDP, the CPI and the GDP deflator are both 100 in the base year, right? They start at 100. So that's what that is. Consider the simplest macro model with demand determined output where AE equals CI. So we have no government or exports. So it's like a closed economy. Suppose actual national income is 900 billion and desired consumption plus desired investment is 890 billion. So actual national income is this 45-degree line here. And then desired is the line that, like, our function that we draw. So I drew these like pretty extremely so that you could see. Desired, so at this point where the dotted arrow is, desired is less than actual. Less than actual. So what is going to happen? So at this point, why don't I graph that out? We haven't seen this graph in a while, so this is our 45-degree line where AE equals Y. 45 degrees. And then here is our AE function. In this case, it equals C plus I. So this is going to be actual and this is going to be desired. So it says that desired is less than consumption because desired is 890 and actual, sorry, not less than consumption. Desired is less than actual. Actual is 900. So that would be a point after equilibrium. So like somewhere over here. We'll say at that point that this is 890 and this is 900. So what's going to happen? So remember that this is, what is this? This is Y. I didn't draw them. I don't know what they are. Pretty sure it's price level. Could be wrong there. Whatever. Can we find it in the graph? We can check. Desired consumption, expenditure, and disposable income. Oh, it's a different graph. A, E, and Y. Okay. I do that a lot when I'm doing tests. Is I'll go through and sometimes it'll give you a hint to another question later on or even earlier in the test. If you're able to find it, it can be really helpful. It can help you in other questions. So like that graph was given to me, and this graph I'm making, so I don't know like what these are. So that's good to know. Okay, so what's going to happen? Firms will see an increase in inventories and they will respond by decreasing output. So this is how much firms are making. But this is how much we want. So they've made more than we want. So what's going to happen is they're not going to be able to sell out everything. So their inventories are going to go up. Because they haven't sold it. And when their inventories go up, they're going to decrease their output because they're like, oh, we have extra inventory. We don't need to make as much. So they're going to decrease their output and they're going to move down here. What's that going to do to national income? Well, we're going to move to an equilibrium point over here, which means that national income falls. So when we are on this side, let me draw this. When we are on this side, anywhere over here of our equilibrium point, we're going to see an increase in inventories, an increase because we're producing more than we want. And what's going to happen is national income will fall because output is going to decrease. On the other side, if we are on this side, that side of the equilibrium point, what I mean by that is like where the dotted line is, like at what national income we are at. If we're on that side, then we're going to see that, like let's say we're over, pick a color. Let's say we're here. Well, now this is what our desired is, and this is what our actual is. So we want more than firms are producing. So what does that mean? That means that firms are going to have to go into their inventories. They're going to have to go back and get all their extra stock and sell that too. So then they're going to go, oh, we're really selling out here. We need to make more inventory. And when they make more, that's more people working. So that's increasing our GDP. So that's going to bring us this way over here. That's going to increase our national income. So in that case, we'd see a rise in national income. All right. What are autonomous expenditures? So those are expenditures that are not dependent on national income, quite simply. So investment is always autonomous. Consumption has an autonomous part to it. We have autonomous consumption, and then we have induced. So our induced consumption is like our disposable income, which is our income after taxes. And then our autonomous consumption is the consumption we consume even if we have no disposable income. Even if our disposable income is zero, we're still going to go out and buy food and stuff, etc. Investment is always autonomous. There's no part of it that's affected by Y, right? Government, same thing. No part that's affected by Y. We assume that to be autonomous. And exports are autonomous, but imports are not autonomous. There is a marginal propensity to import. So that's not autonomous. The simple multiplier applies to short-run situations. Did I get this right? I think so. Pages? Question 20? Yeah, okay, cool. In which the price level is constant. The simple multiplier can be defined by. So this wasn't like super clear to me because it wasn't how I think about the simple multiplier. But what the simple multiplier is it's telling you when there's a shift, how big is the shift. So in this graph, this is our AE, and here's our AE equals Y. Y, AE. I know that now. And here's our, like, Y star or whatever. We don't need that. So this is, remember the second function here, maybe I'll draw that in a different color so that it's clearer. This is the function of our economy, right? And this function is just, this is like just the 45-degree line. It's just like potential output. Okay, so what happens now if we increase one of the variables? So let's increase one of our autonomous variables. Increases in variables. So if we increase an autonomous, what's going to happen? Well, if we increase an autonomous variable, then we are going to change the y-intercept. The y-intercept. And if we change the induced variables, we are going to change the slope. So what do I mean by that? So this function is really, any linear function is y equals mx plus b, right? So let's break down what those parts are. So y is just y, so that's pretty easy. M is our induced consumption, so that is our marginal propensity to whatever. in the case where we have all of our variables, M equals Z, which is the marginal propensity to spend, which is this formula here. Z is equal to MPC times 1 minus T minus the marginal propensity to import. That's not the actual letter for it. I think it's just M, but I like to write MPI because it's a little clearer what it means. So that is the slope of this function. So if we change any of these variables, which you really don't often see, it's pretty rare in questions that you'd see that, you would change the slope. So if you increased the marginal propensity to consume, then that would increase that, right? Because it's positively related. But if you increase the marginal propensity to import, it would decrease that. So what that means, increase, get steeper, decrease, get less steep. That's changing the slope. What's more common is we're just going to see an increase in an autonomous. So that would be little c plus I plus g plus x. So that's autonomous consumption plus investment plus government spending, which includes taxes. Or no, it doesn't. Plus exports. And we sometimes refer to that as little a. So in this case, b in our y equals mx plus b is equal to a. And this x is just our national income, y. So what is this question even asking? Okay, so when we increase any of these variables, how is that going to change our AE function? So let me erase some of this stuff so that we can, it's going to take a long time, just that and this. So let's say that, that's good enough. Let's say that right now we're at 100 and we increase consumption, little c by 100. And let's say that our simple multiplier is 2. So our simple multiplier, remember, is, I know I'm using the same letters a lot, just deal with it, I'm saying them out loud, is 1 over 1 minus z. So that means we also need to know, well, we don't need to know what our z is because we can figure that out. So what that's saying is that if you consume $100 more, it's going to be more than it's going to have more than $100 of an effect on your economy, because you're going to get an extra $5 and you're going to go spend that, and then whatever the Starbucks you bought, now the Starbucks worker gets $3 of that dollars and they're going to go spend that somewhere else, and then that money, like some of them, they spend some of that. So it has multiplying effects. And in this case, we're saying the multiplier is 2. So that means if we increase this by 100, then our actual AE is going to go up by 200. And remember, this is an autonomous variable. So that means we're going to increase the y-intercept. So we're just going parallel shift up. That's the word they sometimes use, parallel shift. And this is going to be our AE2. And where is it going to be? It's going to be at 300 because we increased by 200. So that was, what did we call that? That was the change in equilibrium, the change in equilibriums here, equilibria. Divided by the initial change in autonomous expenditure that brought it about. This one was like, I really didn't like this question because it was kind of hard to I just process elimination this. So national income divided by aggregate expenditure, no, that's not how you find the multiplier. The changes in national income resulting from a change in expenditure multiplied by number of years since the initial change. So I underline years. Years has nothing to do with our formula. So that one's also out. I didn't like that highlight. Years. A change in aggregate expenditures multiplied by the equilibrium level of national income. So we said that simple multiplier is the change in equilibrium, so it's not multiplied by the equilibrium level. And then The change in national income resulting from a change in saving also has nothing to do with saving, so that one's kind of out. This one, the change in equilibrium national income divided by the initial change in autonomous expenditure that brought it about. So the change in equilibrium national income, so this change, right, equilibrium national income down here, divided by the initial change in autonomous expenditure. So we say that this is, I don't want to make up these numbers, it's probably going to go wrong. But divided by the change in autonomous expenditure, 100. So that change divided by 100 would give us 2. I'm not going to make up those numbers and do some math, but that would work. Yeah, trust me. Suppose there is a decrease in the marginal propensity to spend out of national income. The result will be, so what did I just talk about? That is induced, so it's going to change the slope. Marginal propensity to spend is just the whole slope, so if that decreases, the whole thing decreases. So this is our old one, and this is our new one. So it went down. So a decrease in the slope, which rotates it downward. This graph, I don't think we'll see it again because he's already put it on here. It just graphs life and per capita GDP. What is that, like life expectancy? Mean life satisfaction. So the idea is that we learned that per capita GDP is a good measure of like happiness and well-being in your life. So if we look at per capita GDP, like over here, or over here actually is better. All these countries have the same per capita GDP, but their life satisfaction differs greatly. So reading off the graph, at the same level of GDP, subjective measures of well-being can be very different. Just reading off the graph. Per capita, so that's right. We'll go through why the other ones are less right or wrong. Per capita real GDP is not a useful measure of well-being. That is like our definition of well-being, so no. Per capita GDP is very similar at different levels of well-being, so we just proved that it's not. Leisure is an important part of the subjective well-being that is left out of calculations of real capita per GDP. I'm like just going through these, by the way, like I haven't like prepared them, so I'm just like thinking about it like as if I would in an exam setting. So that's like true. The second part anyways, it's left out of the calculation. But I think the idea is that leisure is not an important part of your well-being, I think. And based on the question, which says the information that is conveyed in the figure. So that information is not conveyed in the figure whatsoever. So I wouldn't go with that one. And then the size of the circles are in proportion to the country's population. So let's look at that. That makes sense. USA is pretty big. India is massive. China is massive. Okay, that first part of the sentence is right. Thus, larger countries have higher levels of well-being and higher levels of per capita GDP. Clearly false. Just reading off the graph, clearly false. And these two statements kind of contradict each other. Because if you have a higher population, you're likely to have lower per capita GDP just because there's more of you. So that kind of makes sense. Okay. The slope of the consumption function of the figure is equal to. So this this is like a grade 10 math question. So I hope you guys got this question right. So we're given an x value and a y value and a y-intercept, right? So it says here that 500, these are 1,000. So we have 1,000 is equal to mx plus 500. Right? 500 is our y-intercept. Then it says that x is 1,000, so m times 1,000 plus 500. Bringing that over, 500 equals 1,000 m So M equals 0.5. Boom. In a simple macro model, a decrease in households' wealth is generally assumed to. So if you have less wealth, you're going to consume less. That would make sense. You're not going to consume more, right? You're not going to consume more. And we assume that consumption and saving are built up of our marginal propensities to consume and save, which equal 1. We have like a marginal propensity to consume of like 0.7, say, and that means our MPS would equal 0.3 because together they have to add to 1 because this is a pretty important idea. All income or all money is either saved or spent. All of it. There's nothing else we can do. We either save or spend our money. So MPS plus MPC equals 1. This is not Z. It's not the marginal propensity to spend. It's different. Same acronym, very confusing. David Johnson even admitted it. But these aren't the same thing. Just know that. So it wouldn't affect only saving. Cause no change in consumption because consumption is a function of disposable income only. So a household's wealth is their national income, or their income anyways, not their national income. And disposable income is made up of Y. So that would clearly make that statement false. And cause no change in consumption because the decline is always expected. No, because we have that formula, right? No matter what, we're going to spend a certain proportion, so it's not always expected. This one, identify the aggregate expenditure line from the figures below that describe the economy with the largest multiplier. I went through and did them all. It was really annoying and really tedious, and I thought it was just going to be the one with the highest slope, but it wasn't because all the numbers here are different on the sides. So that was pretty tedious, pretty annoying. So how you do the multiplier is okay. Right, so it's 1 over 1 minus Z, and Z is the slope of the line. So you can figure out the slope of the line. Right, so it gives you 4 data points for each graph. So find the slope of every line. So I did that, and then do 1 over 1 minus that. You'll see which one is the largest multiplier. A lot of them are kind of tedious, but something that's good about this question is, like, as long as you don't mess up putting your numbers into your calculator, you can't get it wrong. There's no real, like, thinking. If you know how to calculate a slope, right? There's no real thinking, so that's kind of nice. The table below shows disposable income and desired consumption for a closed economy. How's my face? Is it like, oh, it's really bright. Okay. Alright, that's better. The marginal propensity to consume is equal to, so disposable income, desired consumption. So we either consume or save our income. So what did we set up here? 50 equals. Okay, so it gives us what our autonomous consumption is, right? When our disposable income is 0, what's our autonomous consumption? Our C function, like what our consumption is equal to little c plus MPCY. Consumption is equal to autonomous consumption plus your marginal propensity to consume times your Y. So get rid of that. That's just what I've written here. So your autonomous consumption is 10, so plug that in. And then just take 1 data point. So plug in 50 as your Y, disposable income, 30 as your desired consumption, and solve for MPC. 0.4. Next one. If disposable income is Y3, the level of desired saving, that's the trick to this. Y3, so coming up this. So this is our difference in, this is actual consumption, this is desired consumption. The difference here between actual and desired is going to be the amount we save. This one, I think I just was like looking at an old midterm or something and saw this, so I got kind of lucky. It definitely threw some people off, and it would probably throw me off if I didn't hadn't seen it before. So that's just the idea that we either save or spend all of our income, and the difference is the saving in this case. If disposable income is 3,000, desired consumption expenditure is equal to 3,000 is disposable income, desired consumption expenditure 2,000. Boom, free mark. Suppose the price level is constant, output is demand determined, and the economy is closed with no government. If the marginal propensity to spend is 0.7, then simple multiplier is 1 over 1 minus 0.7. .33. Our marginal propensity to spend is our Z, right? So that's it. This one, I drew a lot on this graph. Refer to figure if national income is Y1, so here, and aggregate expenditure is AE1, that one, the top one, then desired aggregate expenditure. So just reading off the graph, I labeled what actual and desired was. So this top line here is desired, right? Just tracking over from Y1. And the bottom line is actual, where AE is equal to this national income. So you can see that desired exceeds actual. So desired aggregate expenditure exceeds income. And income will rise. I don't like that word at all. I mean, they're all income, so it has to be that, obviously. And incomes, we know that we're going to go to this point here. We want to go to equilibrium. So, I guess you want to spend more than you can, so it's going to rise. That's kind of strange. I don't remember that, but knowing we pretty much always want to go to equilibrium in the long run. So, at this point, it does exceed it. So we're going to go there, I guess. Which of the following can cause a parallel upward shift in the nx function? So we have two components of the nx function, x minus imports. Remember, imports are induced. They're not autonomous. They depend on national income. So it has to be exports to change. So how do we make this function go up? Exports has to go up because they're positively related. So how do we make exports go up? Okay. An increase in domestic national income. If we are making more money, that doesn't necessarily mean that we're going to export more. Our source of extra income could have come from any number of things, so that's not true. An increase in foreign national income. Well, if another country, like what if the U.S. all of a sudden starts making way more money, then they're probably going to buy more goods from Canada, right? Just because they buy goods from Canada to begin with, and based on that, their imports are based on their national income, right? Imports is equal to MY, which is the marginal propensity to import times your income. So if your income goes up, then this goes up. So you're going to import more. And if anyone's importing from us at all, then they're going to import more now. So that one's good. An increase in domestic prices relative to foreign prices. If our goods become more expensive, why would they buy them? That makes our exports would go down. A decrease in the Canadian dollar price of foreign currency. So it costs a decrease in the Canadian dollar price of foreign currency. That means that the exchange rate has changed, and a decrease in the Canadian dollar price of foreign currency. So if before it cost us 2 Canadian dollars to buy a US dollar, maybe now it costs us 1.5 to buy a US dollar. The point is that it didn't make it better for the US, it made it worse. So they wouldn't import more. and a decrease in foreign prices relative to domestic prices. This would actually not change our exports at all, most likely, based on the fact that it's based on national income. They're still going to import the same amount. However, if everything in their economy was cheaper, then ignore what I said last. It's not going to change it at all. Okay, this one I got wrong. 32. The correct answer is E. Okay. Consider the following information. Equilibrium condition is y equals c plus I. Marginal propensity to consume is 0.9. The autonomous part of C is 300. Investment is autonomous and is 100. Suppose the economy is at equilibrium. Then there's a significant decline in house prices across the economy. The likely effect. Autonomous consumption will fall. Okay. When you buy a new house, if it's already been built and you're not the initial owner, then it's considered consumption. However, if you are the first buyer of the house or you build the house yourself, then it's considered investment. So, if houses significantly decline in price, I'm assuming here that means new houses. That means that we are going to spend more of our money on these new houses, which increases investment and lowers consumption. But that wouldn't change. I don't know. That one's weird. I'll look it up later. If someone can explain that to me, go for it. A movement along the net export function can be caused by a change in. So, net export function. X minus my. So a movement along. What that means is that we're not seeing a shift of it. So if we change exports, then we're seeing a shift. However, because the nx function is dependent, this is what it looks like, by the way, I think. Yeah, because it's a constant variable, that this is x, and then it goes down for my. So how are we going to see a shift in this? Well, this will increase or decrease. So that would be really domestic. Right. Because it's our marginal propensity to import. So that depends on our y. So a change in domestic national income would move us along the curve. Not foreign national income, because that would change exports. That would be a shift. Not domestic prices, because that wouldn't change how much we import or export, right? If we have a change in our prices. The exchange rate. Foreign prices. Would we not import more if foreign prices went down? I think domestic prices and foreign prices are both talking about the exchange rate. Or, sorry, both talking about exports. That's why. Exchange rate. Well, no, okay. The idea is that to move along this curve, we need to change y. That's it. That's what the idea is. So the other ones would, I think, shift them in a certain way. A fall in the Canadian dollar price of foreign currency, all other things being equal, causes Canada's net export function to shift. What happens if there is a fall in the Canadian dollar price of foreign currency? So that means foreign costs less, we import more, and export less. Fall in the Canadian dollar price of foreign currency. So it costs us less to buy foreign currency. The exchange rate goes up in our favor. Our dollar appreciates. So that means that, okay, so if it, writing it out, let's say before costs $2 CAD for 1 USD, and now costs 1.5 CAD for 1 USD. So, what does that mean? It's good for us. It's bad for the US. It's bad for the US because before their $1 was worth $2 here, and now it's only worth 1.5. So we're going to export less. We mostly export to the US. So we're going to export less. So that's going to shift it down. That's going to be a parallel shift. And then, because the exchange rate changes, both parts are going to change. Now, we're going to import more. We're going to import more because now our dollar is worth more in US dollars. It's not worth $1 there, but it's closer. So we're going to import more. Our marginal propensity to import, if we import more, this part goes up. So if this part goes down, erase this. If this part goes down and this part goes up, well, that's positively related. So the first part shifts NX down. And then this is a negative sign, so that's negatively related. So that shifts NX down too. And that's going to make the slope of NX get steeper. The slope will get steeper because this number is getting bigger, right? And that's considered the slope. So we're going to look at something that's more like that. Like that. So that's what that's going to be. Downward and become steeper. This is taking me a long ass time to go through, but oh well, we're getting there. It's an exam. The diagrams show the import, export, and net export functions for an economy. The net export function for this economy, net exports, NX, that's the net export function, goes down. Read off the graph. I laughed when I saw this question because this is the only one that has the right y-intercept, right? None of the other ones have 450 as the y-intercept. You don't have to do anything else after that. That's it. You could now, it gives you enough data points that you can calculate the slope and stuff, but you don't need to. It's the only one that has the right y-intercept. The level of exports is fixed at 300. That's key. All figures in the table and in the questions are in millions of dollars. What is the marginal propensity to import? So that's just the slope of this. So the change in this was 100, change of that was 1,000. So that means for an increase in income of $1,000, we import 100 more. So we import 10% of what our income is, 0.1. What is the function? That. Not s, that's not a thing. There are no minus signs. This is not a minus. This is not a minus. There is no s. And this would be x minus imports. So that's wrong, like 3 times. Open economy with government. So that means it has G, and open means it has exports and imports. Consider consumption function with government and taxes. Given a marginal propensity to consume out of disposable income of 0.8, that's right here, and a net tax rate of 20%, so 1 minus 0.2, 0.8. And the marginal propensity to consume out of national income is. So they didn't actually say spend here. They said the marginal propensity to consume out of national income. The key is that here we have the marginal propensity to consume out of disposable income, which is our MPC, and we know that to be. And consume out of national income is like after taxes and stuff. So that's the same thing as marginal propensity to spend. And there was no import here, so that was easy. Consider the simple macro model. The vertical intercept of the AE function. So where's the y-intercept? That's where all of the autonomous variables, like what they all add up to. So add up every variable that doesn't have y. 120 plus 300 plus 520, that's 0, otherwise it would be a minus, plus 180. Right? Where did I get this one? Oh, and that equals 1,000. Cool. All right. What is potential or full employment output? Okay. So a lot of people for this question probably put maximum intensity of use. Think about that. So full employment is not necessarily when everyone is employed in the economy. Like we have an unemployment rate of 6%. If that is our unemployment rate and we are at potential output, like we're in long run equilibrium, then we're at full employment, even though not everyone's employed. So that's the first part. The second thing is if we know that we can have an inflationary gap, what does that mean, right? That means that people are working harder and longer. So that would never be possible if all of the resources were employed at their maximum intensity of use. We'd never be able to have actual output greater than potential. The best we could do would make it equal. So that's why that one's wrong. Potential output is just at their normal intensity of use. Because we can have inflation. That's why it's D and not E. It's not determined by the government. It's determined by like the Bank of Canada, I'm pretty sure. So it's not that one. The level of output achieved during periods where all labor force is employed. So again, not all the labor force has to be employed for full employment. And the maximum GDP that an economy actually achieves throughout its entire history, again, that's like a worthless measure. There's no point to that. Okay. This diagram shows aggregate expenditure for a hypothetical economy. Assume the following features. Okay. Which of the following correctly describes the consumption function for this economy? So, like, I like to really go through these questions and read what they say, because this is an AE graph, but it said the consumption function. The consumption function. What is AE built up of? AE is built up of C plus I plus G plus NX. So we have these 3 other variables here that aren't consumption that we have to take away from AE to get C. So this is our AE. And then we want to know what is our I and what is our G. So, okay, what's another thing is C has 2 parts, right? C is equal to C plus MPCY. So we have to find out what the change in the y-intercept is, but also if there's a change in the slope. So you can see here it gives you the MPC. And now we want to see if there is any taxes or any imports. So there were taxes. So the slopes of these two, of the AE and the consumption function, won't be the same. But because it already gives you the marginal propensity to consume as opposed to spend, so like this line here doesn't have a slope of 0.75. It's going to be something different because it's going to be 0.75 times 0.8, which is 0.6. So it'll actually be like a little less sloped. So this is a slope of 0.6, this line, and our consumption function would be like a bit higher. So let's take away I plus G, right? So I plus G is 175, and it says there is no foreign trade. So we can get rid of NX, and we know that AE is 250 equals C plus 175? Yeah, 175. So that means C is equal to 75, right? Subtract. C is equal to 75. There's two parts to C. It equals C plus MPCY. Well, we know that autonomous consumption, this should be little c. Little c. So it equals 75 plus the MPCY. Well, we know what the MPC is. It gave it to us, 0.75y. So that gives us C. That's what that one is. So like this one, this formula here describes the AE function. Describes the AE function. If that was AE instead of C, then that would be right. Which of the statement is correct? The notation is the notation in class and in the homework. B is the marginal propensity to consume, and Z is the marginal propensity to spend. Good to know. Okay. So, which statement is correct? So, we'll just go through them. Like, I just went through them all and found out which one was right and which ones weren't right, right? So, I equals 75. So, G plus I, 150 plus 120, that's not 75. So this one's out. Then let's look at this one. X equals 55. So that means the difference between these two has to be 55, right? Because this is plus X and there was no X here. That is 55. What is the Z? Z is equal to 0.75. Okay, so I just checked off this first part because maybe I can just go through and only rely on that without having to do any calculations, and that would be easier. So I did that. This one, G equals 70. So G, I don't know why I've checked that. That's wrong. G does not equal 70, right? Because 0 plus G, we get 50. So G equals 50. That's wrong. M equals 0.31 and B equals 0.75. That's just like confusing. So no. We'll come back to it. We'll circle back. And X equals 55, that's right. So let's find out what the Z is, right? So we know that AE is equal to its y-intercept plus Z times y. And given these data points, we get 800 is equal to 200 plus something times y. Something times y, right? Well, we know that y, in this case, is also 800. 800. So we have, if I rewrite that, we have 800 is equal to 200 plus 800y. So bringing the 200 over to the other side, you get 600 is equal to 800y. Y is equal to 600 divided by 800, which equals 3/4, or 0.75. So that gives us this one. And that says that all the others are wrong because none of the other ones say that Z is equal to 0.75. Not even this weird one. And why this one is wrong? Why this one is wrong? So the marginal propensity to consume could be 0.75, but not if the marginal propensity to import was 0.31. Then it would be different, right? Then it would be different. Alright. Refer to the figure. The rotation from AE1 to AE0 could have been caused by. So going down. So it rotated, so that means we're changing induced expenditures, not autonomous. So let's go through and see. An increase in the marginal propensity to consume out of disposable income. So that's MPC. That would rotate it up, so not that one. A decrease in the marginal propensity to import. So this is our formula, right? I wrote IM here for the marginal propensity to import. So if we decrease that, that again would rotate it up, so not that one. An increase in the marginal propensity to import. Well, now if this number is getting bigger, then that means this number, the Z, is getting smaller, so that's good, that works. A decrease in the net tax rate. That would make this first number here bigger because we're taking a smaller number away from 1, so that would increase the slope again. And a decrease in government purchases, that would shift the whole line down parallel. It would be a parallel shift, so it's not that. So that means it has to be C. Consider the simple macro model with a constant equilibrium national income is. Okay. What we have to do here is we have to solve for this point here. Oh, whoa. We have to solve for that point here. So I'll take a snip of this so solve it. Oh, my fan's going crazy. Whatever. Okay. So what do we see here? So let's we know that AE is equal to C plus I plus G plus NX. Let's actually expand that. So C, little c, plus MPC Y plus I plus G is really G minus T. And I'm gonna put that in. Actually, no, it's just G. We'll just leave it as G. Plus exports minus imports. So that means it equals consumption is 150 plus 0.9 YD plus 400 for investment plus 700 for government plus 130 for exports minus 0.08 Y. So some of these are Y and some of them are YD. So this one that's YD here, that means it's like 0.9 times disposable income, and disposable income, remember, is our Y minus taxes. That's why we need taxes. It's not in the government part. It's Y minus taxes. So this equals 150 plus, try to spread this out a bit, 0.9 times Y minus 0.2 Y, because that's taxes, right? Plus 400 plus 700 plus 130 minus 0.08 Y. Now we can just add these all up together and we're going to get a linear function. So add up all the numbers that don't have Y in them, 150 plus 400 plus 700 plus 130. And that's going to be our Y-intercept, 1380, plus all the numbers that do have Y. So this calculation here is 0.9 times 0.8, 0.9 times 0.8, 0.72, and then minus the 0.08 gives us 0.64, 0.64 Y. And that's like our Y equals mx plus b function. And now what we want to do is we want to make this, our AE, equal Y. So we say this equals Y. And now you just solve. So now we have 1380 is equal to Y minus 0.64Y So 1380 is equal to 1 minus 0.64, which is 0.36. What? Y. And then just divide. 1380 divided by 0.36 gives you 300. So then y equals 3833.33, which is right there, D. Our answer. Awesome. All right, almost done. In an open economy with government and demand-determined output, a decrease in equilibrium level of national income could be caused by a decrease in equilibrium level of national income. Here is our equilibrium level of national income. So a decrease in that. That means that our AE curve would have to shift downwards to get a new one down here, right? Something like that. So how do we do that? That could also be a rotation. Could also be a rotation downwards. That's like a really extreme example, but it would still work. So, a decrease in taxes at all level of income. Well, that would increase. I'll do these all in different colors. So the first one would increase with lower taxes. Next. A decrease in the desired level of imports at all levels in the economy. So if this is our slope, if the imports go down, that makes our slope go up. So with less imports, we have something like that. Just a rotation. Or with greater imports. Is that what it said? Greater? Sorry, decrease. In the IM. Next one. An increase in desired consumption. Desired. So not autonomous, desired. Same thing. It would also increase the slope. An increase in the desired level of savings. So notice it says desired again, not autonomous. That means we've changed our marginal propensity to consume. We've decreased it because we've increased our marginal propensity to save. So that would rotate our curve downwards. Rotate our curve downwards. Higher MPS, that marginal propensity to save. That one's good. And an increase in government purchases would be just a straight shift upwards. So we get that one. D. Nice. Suppose aggregate output is demand determined. If the marginal propensity to spend is 0.5 and MPC is 0.7, a $1 billion reduction in government purchases will cause equilibrium national income 2. This is just using the multiplier. So it gives us spend, so we can actually ignore that. We just ignore it. So we know that the multiplier is 2. 1 over 1 minus z gives us 2. So it would decrease it because it's a reduction in government purchases, right? AE going downwards. How much is it going down by? It's going down by the initial shock times the multiplier. This one. I got this wrong, but I liked my process in this. So, 47. Alright. So, refer to figure 22.5. Diagram 2. So this diagram 1, I just instantly scribbled out because I didn't want to look at it anymore. I didn't want it to confuse me. Get rid of it. You don't need it anymore. Then I also always confuse which one is actual and which one is desired, so I labeled them. 45-degree line is actual. That's good labeling. It's in experiencing what kind of gap? So I said it was an inflationary gap. So let's see. Actual is greater than desired. So that means potential. This is potential output here. Potential output. And at potential output, desired is less than actual. So that puts us in a recessionary gap. Interesting. That's the opposite of what I said. Yeah, because the right answer is E. So that's... Alright, how does that work? So at potential, we don't want as much as there has been made. So that means that there's a lot of stuff in this too. Like y0 is totally pointless. Like, because we're only looking at y star. Y star is potential. Would be to increase national income. Right now, our income, the goal of the stabilization policy would be to increase national income until it was equal to potential GDP. So, I think we're at this point, and then we want to go to this point at potential, but at that point they're not equal. I don't like this one either. Someone can tell me this one. That'd be helpful. I don't know what that one is. That one's throwing me off. The Economist magazine at the end of each issue presents a table entitled Economic and Financial Indicators. One such indicator is an interest rate and the other is the last 12-month inflation rate, both expressed in annual terms. The highest real interest rate found is real is equal to nominal minus inflation. Just do them all. Peru by far has the highest, right? I just did them all. You find the highest. That's it. Which of the following is an accurate statement about real national income? It always equals nominal national income. Nope, we have inflation. I got this one wrong too. The answer is E. Or no, the answer is C. This is the right answer. It changes by the same amount and in the same direction as does nominal national income. Again, no, because we have inflation. It changes only when the underlying quantities of output change. True, because it has to do with GDP. Come back. It refers to the national income with no adjustment for changes in prices. No, real means it's been adjusted for prices, not that one. It refers to national wealth, but is not an indicator of current production. I think this part's actually false. I think it is an indicator of current production. That's why it's false. So that means it has to be C. It's just weirdly worded. It changes only when the underlying quantities of output change. Underlying quantities of output change. Wouldn't it change with inflation as well, though? Weird. I don't know. This one, I hate. This question is stupid. I really didn't like it. Total guess. Thanks to a healthy consumer. Okay. As the financial crisis proceeds into distant memory, U.S. householder finances are looking better by the year, with the American consumer poised to keep the world's largest economy solidly on the right course through the 2020 election. Wealth is hitting record highs. Workers are pocketing bigger wage hikes, all signs that Americans have room to spend. So, there is obviously an increase in autonomous consumption because our wealth has gone up. Right? Oh, actually, no, this makes sense. So, we've gotten more money. So, obviously, we are going to consume more. And, what does that mean? We have C is equal to little c plus cy. And because our y has gone up, we're going to move upwards along the curve. So we're going to see a shift up because our autonomous consumption is going to change, and a movement along because we've gotten more income. Okay, that was a really long video. I'm sorry, the ones I got wrong, I don't really know why I got them wrong still, so that's like a bummer, but oh well. I did my best. If you guys want me to make these videos for like other classes, like I might make one for accounting. I'm not like amazing at accounting though, but I'll definitely make like more of these for the final, and then maybe some other classes. We'll see. Let me know. Maybe BBA. I don't know.